Right, diving in today, and we're looking at something pretty fundamental to AI, this whole idea of overfitting, right? You sent over some really interesting stuff about how these models learn, but sometimes it's like they learn too well, and then new stuff throws them off completely.
Yeah, it's a bit of a paradox, isn't it?
It is. So our goal today is to break this down, use the examples you found, and really show how even little quirks in the data can make a huge difference in how these systems interpret, well, everything.
I think that YouTube transcript from Coup Research you sent is perfect for that. They use those scenarios with foxes and apples, really visual, gets the point across quickly.
Okay, so let's start simple. Overfitting in a nutshell. It's like when an AI memorizes its training data so perfectly, it gets hung up on all the noise, the little details, instead of getting the bigger picture.
Exactly. Imagine a student who just crams answers for a test instead of understanding the material. Change the wording slightly, they're lost.
Right, and that's exactly what we see in that first example, the Arctic foxes, an AI trained only on white foxes. What happens when it sees a gray one?
Well, it doesn't see an Arctic fox at all. It just misses it completely.
And it shows you how literal these systems can be.
Yeah.
Because it only saw white fur, that became the defining feature for it. No variety in the data, so it couldn't grasp that Arctic fox can mean different colors.
Exactly. Its ability to generalize was totally limited by the data. But then you've got that example with the single green apple. What happens when it encounters other green apples?
This is where it gets interesting. It still gets it right. Recognizes them as apples. One single example was enough for it to pick up on, I don't know, the essence of an apple, I guess.
And that's so important. It tells us that even a small sample, just one, can be enough if it captures those core features. But then that example with the apple on a branch, that throws a wrench in things.
Oh, yeah. So green apple, by itself, the AI gets it right 93, 94% of the time. Put that same apple on a branch. Suddenly, it's a tree with 99% confidence.
Big jump.
Yeah.
And the transcript makes a good point. The training data probably had way more pictures of apples on trees than just apples by themselves. So the AI learning, it latched onto that more frequent connection.
So instead of thinking plant, then fruit, then apple, it goes plant, tree, apple, tree. That branch became the dominant feature because it was so tied to tree in the data. Shows you how much those common patterns influence the AI's perception.
Huge takeaway for our listeners, right? We see that even one good example can lead to some generalization, but those dominant patterns in the data, that's what really drives how the AI classifies things. And flip side, if there's no similar example, like that gray fox, total misidentification.
It makes you realize just how crucial it is to have that diverse training data. If you want an AI that can actually handle new information, you can't skimp on variety.
Exactly.
So I guess what we've learned is the quality, the variety of that training data that shapes the entire understanding of the AI.
Yeah.
The apple on a branch thing. Perfect example of how even a tiny detail, the background, can lead to a wrong answer.
And that leads to, I think, a really interesting question. If the AI decided tree was more important than apple because of its training, what other things are we taking for granted? What else might these systems be misinterpreting because of how they were trained?
What kind of connections are they making that we don't even see?
Yeah.
And what does that mean for how we use AI in the future? Makes you think.
It really does.
Thanks for taking this deep dive with us. This stuff is always so fascinating to unpack.
Absolutely. It was a pleasure.